Hello, this is Mr. Gilmore with the 6.2 Quadrilateral Properties and Tests. We're going to see that there are many properties to quadrilaterals, especially our quadrilateral families, the parallelograms, the kites, and the trapezoids. Now, will we prove all of these properties? No, we will not. However, we will look at a few of those properties. We will conclude today's lesson by looking at what we call the quadrilateral tests. In other words, let's say I give you a quadrilateral with certain features to it. What you can then conclude is that that quadrilateral is of a certain kind. For example, let's say that I give you a quadrilateral that has equal opposite sides. It is then provable that that quadrilateral is a parallelogram. We're going to take a look at some of those tests at the end of today's lesson. Let's start with our parallelogram properties. These are all provable and highly useful. The parallelogram comes with many different properties that we can actually use then, especially when we're attempting to prove things. So if we take a look at these three in the list, we can prove all three of these, that opposite angles are equal, opposite sides are equal, and that the diagonals bisect one another. I'm not going to ask you to prove all three. I'm going to ask you to prove the last one, that diagonals bisect one another. I will set that up for you on the homework assignment, and then you will go and prove that that is true. Now, some advice going into that proof. The order in which we would prove these properties is in fact the order we see them here. We would start by proving that opposite sides are equal, then prove that opposite angles are equal, and then prove that opposite sides are equal, and then we can move into the diagonals bisect one another, which means you can use the previously proven properties to help you in your adventure for that third property. Now, we're going to get tired of writing down the word parallelogram over and over again, which means I would suggest you shorten it up to just the word p-gram. And these properties, they're all lumped together into the parallelogram properties. And essentially then if we are reasoning with them, we're going to say that these are called the p-gram properties. All right, so you can be more specific if you like to within your proof. However, p-gram properties is enough then to justify that you know the properties of parallelogram. Some other useful properties that we have with our other family members, right? We have the rectangles and rhombuses and squares and the kites and trapezoids. What are some other properties that come along with those? So here's some useful properties. Rectangles have equal diagonals, rhombuses have perpendicular diagonals, and the square actually inherits all the properties that are provable for the parallelogram, the rectangle, and the rhombus. So anything true about those three is also going to be true about the square. The kites have perpendicular diagonals, and trapezoids have supplementary same leg angles. These are the angles that are formed on a leg. Now, the isosceles trapezoid actually has two properties to it. It has equal diagonals, and it also has the equal same base angles. So the base angles, right, the angles that are formed on a single base, those are actually going to be equal to each other in an isosceles trapezoid. Now, I'm not going to ask you to prove all of these. However, on the Postulate Theorem handout, right, this is what we typically call the Postulate page, you're going to find in the Chapter 6 section all the properties that are provable about these family members, about the parallelograms and the kites and the trapezoids. So I want to impress upon you the importance of knowing these properties. I'm not going to ask you to prove all of them, but I am going to ask you to know them, which means pick up that Postulate Theorem handout and read through those properties. There's a lot of good ones. In fact, that's our critical source for our quadrilateral properties. So whenever we encounter a quadrilateral, we're going to then use our Postulate Theorem handout as our main source of reasoning as we dive into that quadrilateral. Let's now finish off the assignment, or finish off this lesson by looking at the logic of the tests. So if we're given a quadrilateral that has certain features to it, then it's possible that that quadrilateral is of a certain kind. In other words, let's say we're given a quadrilateral with equal opposite angles. It's provable then that that is in fact a parallelogram. And we're going to find that there are tests for our other family members, that there are rectangle tests, rhombus tests, there's isosceles trapezoid tests, and all of these are provable. I'm not going to make you prove all of them. I'm going to make you prove one of the parallelogram test, or the parallelogram test that we'll take a look at here in just a minute. So when we arrive to a quadrilateral with given information, we can actually use that given information to determine if it's a specific kind of quadrilateral. So for example, let's take a look at the parallelogram tests. Okay, there are really 4 parallelogram tests. Here are 3 that are going to be useful. Okay, as it turns out, each one of the parallelogram properties that we saw given to us are actually to have true converses. Now, the one that I did leave out was that if you're given a quadrilateral that has equal that the diagonals are bisected bisecting each other, then in fact that would be a parallelogram. But these are three extremely useful parallelogram tests when jumping into a quadrilateral with certain features. So let's say we're given a quadrilateral such that it has opposite angles that are equal. It's then provable that it's a parallelogram. Let's say we're given a quadrilateral it's such that opposite sides are equal. It's again provable that it's a parallelogram. Now the last one is an interesting one. Let's take a look at the third one here. If we're given a quadrilateral such that we have one pair of opposite sides that are equal and parallel, it is provable that that is a parallelogram. And I'm going to ask you to prove that one on the homework assignment, okay? That if you're given a quadrilateral with one pair of sides that are equal and parallel, it then is provable it's a parallelogram. Here's my advice to you. Draw in a diagonal, because a diagonal in a quadrilateral cuts it into triangles, and we can do something with those triangles. Now, again, all of the parallelogram tests, we can distinguish them more specifically in a proof if we wish. However, we're going to lump them all together under what we call the p-gram tests. Okay, so if we're justifying something of why we know a quadrilateral will be of a certain kind, we can then justify it using the p-gram tests. Now, there are other useful tests. Again, we have other family members in our quadrilaterals. Let's take a look that there are some actually involving rectangles, rhombuses, and isosceles trapezoids. So a parallelogram, notice that we're given a parallelogram, is a rectangle if it has equal diagonals. So if we're given a parallelogram that has an equal pair of diagonals, then it's provable it's a rectangle. Another useful test is that if we're given a parallelogram, again, given a parallelogram, we can prove that parallelogram is a rhombus if its diagonals are perpendicular to each other. It's then provable that it's a rhombus. Another useful test is that if a quadrilateral is a square, if it's provable to be both a rectangle and a rhombus. So if you can prove that a quadrilateral is both a rectangle and a rhombus, then you can specifically call that a square by definition. And the isosceles trapezoid actually has tests. So if we're given a trapezoid and we want to prove it's isosceles, there's a few different features that we can be given with this one. We can prove it's isosceles if it has a pair of equal same base angles. So these are the angles that are formed along the same base. And we can also prove it's isosceles, a trapezoid, if the diagonals are equal. Now, again, I implore you, I beg you, right? I want you to go to that Postulate Theorem handout and read up on the quadrilateral tests. These are all found in the Chapter 6 section. You're going to find that there are a good number of the quadrilateral properties for each of our family members and a good number of our quadrilateral tests. I implore you to know these, okay? So please, please, please go and read those. They're going to help you with this worksheet. They're going to help you in your proofs. They're going to help you arrive to justifications based on what you know about a given quadrilateral, whether it's a parallelogram or one of its family members or kites or trapezoids. So we've come to the end of our lesson 6.2. If you do have any questions about this homework assignment, please do not hesitate to email me. With that, be good and do good.